Next theorem is Millman's theorem. Millman's theorem statement: in a network, if it contains several voltage sources like E1, E2, E3, etc., with an internal impedances Z1, Z2, Z3, etc., which are connected in parallel, may be replaced by a single voltage source E with an internal impedance Z, where E and Z are given by these values. E is equal to E1 Y1 plus E2 Y2 plus E3 Y3 divided by Y1 plus Y2 plus Y3. We are considering only 3 voltage sources. You can see the diagram here down. Okay. So there are 3 voltage sources, parallel voltage sources E1, E2, E3 with internal impedances Z1, Z2, Z3. You can consider any number of voltage sources. Okay, you can continue with E4, E5 extension you can do. So in general, here we wrote only three voltage sources E1, E2, E3 are connected in parallel with each other. So 3 voltage sources are connected in parallel with internal impedance Z1, Z2, Z3. We can also rewrite. Okay, we can also rewrite the statement as with resistance only. Okay, if you consider instead of impedances, you can also write in a electrical network if it contains several voltage sources E1, E2, E3 with internal resistance R1, R2, R3 which are connected in parallel may be replaced by single voltage source E with internal resistance R. Okay, where E and R are given by that. So in general, we can write impedance. If it is a resistance, so reactance will be absent, only resistance will be there. So in general, I am writing here. So what is the value of that? If I write here uh, one value, okay. So we can write into single voltage source. We can convert this entire source into. We can convert this entire into single voltage source with internal resistance or internal impedance. Okay. This is E. This is equivalent Z. So you can convert this parallel instead of these three. We can write into single voltage source with internal impedance Z. Or if you are writing in terms of resistance, we can convert into single equivalent resistance. So this is a statement. So we have to we got two expression. The resultant E is given by E1 Y1, E2 Y2, E3 Y3. Okay. So we can also write in terms of resistance as E1 R1. Okay. For example, here if I write if it is resistance, so you can write it is E1. Y1 means actually for impedance reciprocal is admittance. For resistance it is nothing but reciprocal is conductance. So E1 G1, E2 G2. For resistance I'm talking. So E2 G2 and E3 G3. This is if you consider only resistance, not and here also here y1, y2, y3 is there, no? So that is a reciprocal of impedance. So here also you have to write G1, G2, G3. This is if you write only resistance here. Instead of this, we can write here resistance symbol, write R1, R2, R3. Then this is the formula. So now let us go to the proof of this one. So here 3 voltage sources are there, no? So using source transformation technique, we can convert these voltage sources into current sources. So these two, for always voltage source, we have a series resistance. Here it is a AC source, so it's series impedance. We can convert this first one E1 Z1 voltage source into current source. If we convert, okay, so the value of the I is given by I1 is given by E1 by Z1, okay, or E by R, okay, E by R, that is the value of current. So this current value is E1 by Z1. Similarly, convert and same Z1. See whatever Z1 is there here, same Z1 you have to connect parallel between this node and this node. voltage source is that you are converted between same two nodes, we converted into voltage value, and same Z1 is connected parallel. Similarly, second voltage source E2 Z2 is converted into current source. Again, divide voltage by impedance. I2 is equal to, it is E2 by Z2, and same Z2 is connected parallel. Similarly, three voltage sources we consider. So third also you have to consider. If you have n number, you have to convert n times. Okay, in general, this is Z3. Okay, now we converted three voltage sources into three critical current sources. Now between A and B, three currents are going upwards. Okay, three currents are going upwards. We can add all the currents, and three impedances Z1, Z2, Z3 are connected in parallel. So we can add in parallel, we can add the currents. So I is equal to, the net current is equal to I1 plus I2 plus I3. So while writing arrow mark, current arrow mark. So here AC problem, uh, they will not give any, if they give DC voltage sources. So you have to consider plus minus here. In parallel, we are adding currents I1, I2, I3. So if you add all these currents, you are going to get three currents we added now. So I1, I2, I3 is given by, okay, E1 by Z1 plus E2 by Z2 plus E3 by Z3. So these are the three currents we added, and in parallel combination, okay, if three resistance are connected, three impedance or resistance connected in parallel, 1 by Z equivalent is equal to 1 by Z1 plus 1 by Z2, 1 by Z3, because these three are in parallel. Z1, Z2, Z3 are in parallel. So 1 by Z is equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3. So now we can convert, we are added all the current, okay, per currents, and we got net current. Here we are getting net current as I, which is E1 by Z1, E2 by E2 plus E2 by Z. Z2 is this Z2, and E3 by Z3, and Z is equal to, actually 1 by Z is equal to 1 by Z1, 1 by Z2, 1 by Z3, and Z is equal to reciprocal of that, because it is 1 by Z equivalent is equal to 1 by Z1, 1 by Z2, 1 by Z3 here. So Z is equal to, you have to take 1 by Z is this much. Okay, 1 by Z is this much. So Z is equal to reciprocal of this. So that is the value of Z here. Now again convert this current source. Current source parallel with the impedance, if you convert back, again this V is equal to I into Z. E is equal to I into Z. Whatever value of I we got here, you have to multiply with Z. That is the value of E, and value of Z is this. So same formula we have written there. Okay. So here you can see E is equal to I into Z. I value is sum of currents I1 plus I2 plus I3. Z equivalent is this. Okay. Here I don't know. You have to multiply with Z. I into Z. Z is this. So here you can see this is current. Okay. This one is current multiplied by 1 divided by 1 by Z1, 1 by Z2, 1 by Z3. It is same as that. Okay. So now this can be written as E1 by Y1, E1 by Z1, E2 by Z2, E3 by Z3. You can write like this, or this is the option. You can write E1 Y1 plus E2 Y2, where Y1 is 1 by Z1. Okay, where Y1 is 1 by Z1, Y2 is 1 by Z2, and Y3 is 1 by Z3. You can use this formula, above formula, or you can write in terms of admittance. Z means impedance, Y means admittance. In terms of resistance, E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. You can write like this, or you can write E1 G1 plus E2 G2 plus E3 G3 by G1 plus G2 plus G3 if it is a resistance. Okay, so this is how to calculate. And after that, we have converted the three parallel sources. These are the three parallel sources, right? So these three parallel sources, E1, E2, E3 with internal impedances Z1, Z2, Z3 are connected in parallel. That can be converted into single voltage source. I already told this. So the application of Millmans theorem is, if many voltage sources are connected in parallel, we can convert it into single voltage source. Now you converted into single voltage source. This is equivalent source, single voltage source. So like here, this is we obtained from Millman's theorem, Millman's equivalent circuit. And you have to connect same ZL here. You have to connect load. If you have to connect the load here, where that load will be there means here somewhere load will be there. Here, some ZL will be there. So same ZL you have to connect here. You have to connect here. After that, we can write here. Okay, now how to find a current through this load impedance or load resistance. I am telling once again, if it is resistance network, we are going to get effective E and equivalent R here, and this will be RL. And you can find the current through this. Current through this one is given by voltage divided by sum of resistance or impedance. Here, this is a series circuit. Z and ZL are in series, and in the entire circuit, voltage is E. So E divided by Z plus ZL. Z is this, which is Millman's equivalent resistance or impedance, and this is E is Millman's equivalent voltage E, and ZL is load impedance. So Millman circuits E divided by Millman's resist impedance Z plus ZL. So this is Millman's theorem. Okay. So if they ask state and prove Millman's theorem, you have to write the statement. Okay. Then how we got this expression? How we got this expression? This is the value of E, no? How we got this expression means you have to prove this much. Okay. So based on this, they are going to ask. This is a very, very important theorem. So in the exam, easily you can get 8 to 10 marks. Okay. If they ask AC problem, they'll ask for 8 marks. If they ask state and prove means they'll ask for 10 marks. Otherwise, around you can get 8 marks. So next video, you can see the problem. Thank you.